Sometimes we come across moment problems where instead of having a point load, we have something called a uniformly distributed load. That's where the load is spread out over a larger area. And instead of giving you the force in newtons, you're given a force distribution in newtons per meter. So in order to replace this and turn it into a point load, you need to multiply what you have here, the distributed load, the uniformly distributed load, and you multiply it by the length that it's distributed across. So here you would be multiplying the 2 kilonewtons per meter by 4. That would give you a load of, let me write that, so 4 times 2,000, 8,000 newtons. And where we would place it would be in the middle, in the center of the 4 meters. So it would be 2 meters from either side. So actually, let me draw a longer arrow. That is your uniformly distributed load. Okay, so now we can ignore that because it's been replaced by that. And we just need to label this distance here as 2 meters and this distance here as 2 meters. So it's in the center of that. So you do that whenever you see you have a uniformly distributed load. So this question is asking for the reaction forces at A and B. So we're trying to find the reaction force at A and the reaction force at B. So if we call this force B and we call this A, you would do this using the principle of moments that says that the net moment needs to be 0. And in this case, you'd say the net moment, the net clockwise moment would be equal to the net anti-clockwise moment. And you can choose either of these as your pivot. So I'm going to choose A as my support and say the summation of clockwise moments around A is equal to the summation of anti-clockwise moments around A. Okay, and I'm going to circle A to make it clear that I'm using A as my support. So, which forces contribute to a clockwise moment or a clockwise rotation? So this one clearly is clockwise, and this one is clockwise, and this looks like it's anti-clockwise, and we don't count the reaction at A because it passes through the support, so the distance will be 0. So we don't count that, we only count this, this, and this. So the 8,000, we're going to multiply by the distance here, which is 2 meters. It's the distance between the force and the support. So we have 8,000 times 2. And we also have the 5,000, that's the kilonewton, multiplied by this distance, which looks like it's 2 plus 2 plus 1, 5. So it's 5,000 times 5. And that is equal to the anti-clockwise moment, which is B, which is turning the beam anti-clockwise. So it's B multiplied by this length, which is 2 plus 1 plus 2 plus 2, which is 7. So it's 7B. So we can calculate B directly from that. As 5,857.1 Newton. So now we've found the reaction at B, we still need to find the reaction at A. And to do that, we use Newton's first law. We say the sum of moments, the sum of forces needs to be 0. So the summation of forces needs to be 0. For this object to be in equilibrium, all the forces added together have to be 0. So the forces pointing up are going to be positive. The forces pointing down are going to be negative. So I'm going to say A plus B minus 5,000 minus 8,000 equals 0. So that these are the two forces going up, and these are the two forces pointing down. And because we've already found B, we can simply find A by subtraction. So A gives me 7,142.9 newtons. So that's my second reaction. So we found our two reactions using the principle of moments and using Newton's first law, the law of equilibrium. We could have taken moments around B, and that would have given us A directly. And it's an equal amount of work if you were to do it using the principle of, or the equilibrium principle or the principle of moments. It's an equal amount of work. So you could have chosen A or B to take your moments around. But the important thing is that when you come across a uniformly distributed load, you multiply the load by the length that it's distributed over to give you your total load. And then you put that in the center, and then you just ignore the original UDL. I hope you found that helpful.